Campbell River, British Columbia, recognized as a world-class tourist destination. Here, visitors and residents alike are attracted to the area's natural and unspoiled beauty. Tourists journey to this Vancouver Island community in search of the mighty tidy salmon and for the adventurous hiking trails, whale watching, and endless scenery. While enjoying activities here, we are reminded that Campbell River's economy is strongly tied to several major resources, including aquaculture, logging, pulp and paper, and mining. The Quinsam Coal Mine, located approximately 28 kilometers southwest of Campbell River, or 200 miles north of Seattle, Washington, is a contributing industry to the Campbell River economy. With a workforce of over 55 full-time employees, the mine has been providing domestic and offshore customers with good quality steam coal since 1987. The high volatile bituminous coal mined at the Quinsam mine site is low in sulfur, which along with its high thermal rating makes it ideal for thermal steam generation and therefore a highly sought after product. Quinsam Coal's customers include power utilities in Tacoma, Chile, and Mexico. Other customers include Japanese steel mills that use the coal for pulverized coal injection purposes. Quinsam Coal's primary customers include cement plants in Richmond, BC, and Seattle, Washington. Cement plants use Quinsam's coal as a heat source for their rotary kilns. The ash from the burnt coal forms a part of the clinker that is ground into cement powder. Cement from Quinsam Coal's customers has been used in the construction of many major North American projects, some of the more notable being Vancouver's GM Place and Vancouver's SkyTrain, as well as Safeco Field and Seahawk Stadium in Seattle, Washington. Projects of this magnitude are examples of how the coal from the Quinsam Coal Mine has helped fuel the economy of British Columbia and Washington State. For many years, coal was known to lie beneath the surface here, but it's only in recent years that this resource has become a sought-after commodity. In 1920, prospectors that were part of the Geological Survey of Canada discovered outcrops of coal near the Quinsam and Iron Rivers. The deposits were too far from tidal waters to be mined economically at the time, and as a result, the valuable coal seams were left in the ground for decades. In 1975, the Weldwood Logging Company, in a joint venture with Luscar Limited, conducted an exploration program that consisted of approximately 500 boreholes. The initial exploration outlined 20 million tons of mineable coal. 8 years later, the first public inquiry was held, and in 1986 the mine plan was finally approved. Coal production began with the first open pit mine operation in 1987. Quinsam Coal Corporation, a 100% wholly owned subsidiary of Hillsborough Resources, acquired the property from Brinko in 1992. Currently, the mine has an average annual clean coal production of over 300,000 tons. Peak production occurred in 1997 with over 1 million tons of clean coal.
With the recent acquisition of high-performance mining equipment, Quinsam Coal has been able to increase its productivity by 30%, far exceeding expectations. Quinsam Coal's successes have also been due to our use of proven mining methods and technology used throughout the North American coal mining industry. This, in combination with the 2001 drilling program that discovered additional tonnage and the opportunity for future contracts with the pulp and paper industries, has positioned the mine for not only a secure future, but an exciting one as well.
Coal is organic rock that is formed in the earth by the decomposition of ancient plants millions of years ago by processes involving moisture, pressure, temperature, and time. At the Quinsam Coal mine site, good quality coal is located anywhere between 30 and 180 meters beneath the Earth's surface. Initially, the method of coal extraction was by open pit mining due to the coal's close proximity to the surface. By 1994, mining by open pit method was no longer economical due to the greater depth of the coal resource. Since that time, room and pillar underground mining has been the exclusive method of extracting coal. The coal mining process begins first with the exploration of the coal reserves to determine the quantity and quality of the coal. This is done by a team of qualified geologists and engineers. Once the coal reserve has been defined, it is up to the concerted efforts of mine engineers to develop detailed mine plans that outline the method of coal extraction. The extraction of the coal that lies deep beneath the Earth's surface is done by skilled and experienced coal miners. Once fully equipped with rescue and protective equipment, the miners are transported in a mechanical man carrier. Their journey takes them over 3 kilometers in and 60 meters below. Often working with only a single miner's lamp, here at the coal face, great care is taken to secure the rock above. Mining will only be carried out under the safety of a secured roof. This is done with the application of steel mesh and 8-foot-long bolts throughout the tunnel. With precautionary measures in place, the miners extract the coal product using heavy equipment such as the remote-controlled continuous miner. All heavy equipment used underground is specialized for underground conditions. In particular, equipment is specially designed to work around methane gas, a naturally occurring, highly flammable gas that is released from the coal during the mining process. For added safety, the continuous miner is designed to monitor methane gas concentrations and is programmed to shut down if methane gas readings reach an unsafe level. Once the coal has been removed from the tunnel wall, an electric shuttle car transports the coal to the 3-kilometer-long conveyor belt that carries the raw coal to the surface. On the surface, a front-end loader collects the raw coal and transports it to the preparation plant hopper. The hopper then feeds the raw coal into a crushing and screening circuit. Here, the coal is screened and crushed to less than a 2-inch coal fraction and is transported by conveyor for further processing. The coal is put through a heavy media bath circuit that separates the coal product from the refuse material. A heavy media cyclone removes the waste rock from the raw coal. Next, the coal is put through a water-only cyclone. A classifying cyclone sizes the fine, clean coal. And finally, the clean coal product is conveyed to the stockpile. In the on-site laboratory, testing is performed daily to the clean coal for quality, including sulfur, ash, and moisture content, before being shipped to the storage terminal. From the clean coal stockpile, the coal is loaded into 42-ton capacity B-train trucks. The tarped loads are hauled approximately 30 kilometers to the barge loading facility located at Middle Point, just north of Campbell River. The coal is temporarily loaded into a 15,000-ton storage dome and is later transported via underground conveyors to the loading barges. The barge loading facility can accommodate barges up to a 10,000-ton capacity. However, barges with a 5,000-ton capacity are commonly used. From the barge loading facility, the coal is barged directly to customers in Vancouver, Seattle, and Tacoma, or taken to the ship loading facility on Texada Island, located approximately 50 kilometers south. This facility is specially designed to accommodate the loading of oversized ships that are able to transport the coal to overseas markets. These ships include the Handy-size with a 35,000-ton capacity and the Panamax-sized with a 65,000-ton capacity. At the Quinsam Coal Mine site, safety of the employees and visitors to the Quinsam Coal Mine is a vital aspect of mining operations. Striving towards an outstanding safety record, Quinsam Coal has developed a training program in coordination with their Occupational Safety Committee to promote communication between employees and management. This program has significantly increased their safety standards and has brought recognition from the mining industry. As a result, Quinsam Coal is the recipient of the John T. Ryan National Safety Award by the Canadian Institute of Mining and the BC Small Mines Safety Award for 3 years running. The approximate 300-acre subdivision that makes up the Quinsam Coal Mine site is located in an environmentally sensitive area. The mine is in close proximity to Long Lake, No Name Lake, Middle Quinsam Lake, and the Quinsam River, which are important not only to the ecology of the area, but also to the user groups such as the Quinsam Hatchery, which operates downstream of the mine site. It is for these reasons that Quinsam Coal maintains an extensive environmental management program defined by the requirements of the permits that regulate the mine. An on-site environmental engineer coordinates with the regulatory ministries and independent consultants to develop and monitor environmental systems and programs that best protect the environment. One such system is the settling ponds, sumps, and ditches that make up the water management system designed to manage the water from the underground workings and from overland flow. A primary function of the water management system is to control sedimentation that is caused by land disturbance. This is achieved by the collection and retention of the mine water to allow for adequate settling before discharge into the environment. A system of silt berms located in the drainage ditches provides additional control of sedimentation. Water quality is monitored on a regular basis at numerous designated monitoring stations, including the 2 main points of discharge located in the main settling ponds and in each of the 3 lakes. Detailed physical, chemical, and biological analysis of the water samples is performed on a regular basis as outlined in the environmental permits. 4 times a year, samples of the discharge water from the north and south settling ponds are sent to an independent laboratory for bioassay testing. The bioassay is a toxicity test that determines the survival rate of fish fry that are known to be very sensitive to anything abnormal in the water.
What we have here is a typical single concentration screening test, and what we do is, this is strictly 100% test solution where we take the respective sample and add it into the tank. Through the 96-hour period, we do various water quality parameters. We do survival, we do pH, we do dissolved oxygen.
There has always been a 100% survival rate of the fish fry that are tested in Quinsam Coal's discharge water. Another important system for the protection of the environment at the Quinsam mine site is the refuse management system. A fine refuse impoundment system and a coarse refuse storage area were designed to manage both the fine and coarse coal refuse that is generated at the mine site. Quinsam Coal Corporation is a member of the Environmental Technical Review Committee, which is comprised of members of the Ministry of Land, Water and Air Protection, Fisheries and Oceans Canada, the District of Campbell River, the Ministry of Energy and Mines, and Environment Canada. It is the task of the committee to review water quality data on an annual basis to monitor trends or changes in the data and to make recommendations as required. It was through this process that the issue of increased sulfate concentrations in the receiving environment was identified, prompting sulfate to become a focal point of the water quality monitoring program. Sulfate is a naturally occurring mineral salt that is found in groundwater and surface water. Concentrations of sulfate in the discharge water at the mine have been increasing due to the natural abundance of sulfur in the rock that is disturbed by the mining process. Although there are no permitted limits for sulfate at the mine site, a provincial guideline of 100 milligrams per liter applies to receiving environment. Quinsam Coal is diligently working with the regulatory ministries and independent consultants to develop a system that will reduce the amount of sulfate reaching the receiving environment. The initial step is to pinpoint the sources of sulfate at the mine site and then develop a system that reduces the sulfate concentrations at these locations. Working towards this goal, Quinsam Coal has obtained the services of Golder Associates to install 8 groundwater wells in the areas that have been identified as possible sources of sulfate in groundwater.
What this is here is a groundwater monitoring well. We've installed 8 of these around different areas of the mine site to monitor the groundwater. This is one of the things we've done to address the issue of the sulfates on the mine site. So once every quarter we get an independent consultant to come in and sample these wells. They come in and they sample the water. We've got a water sampling hose here that we just pump out the water. It might take a minute here. You can see here water coming out, and this is sent off to an independent testing lab for analysis.
Quinsam Coal has also installed a culvert pipe in the wash plant discharge water ditch, which has been identified as a possible source of sulfate.
What this is here is a sulfate reducing test cell that we've installed that promotes the growth of sulfate reducing bacteria. What we're doing with this test cell is to see how effective it's going to be at reducing the sulfate concentrations in some of these streams on the mine site. Depending on the effectiveness of this test cell, we'll install these cells in other areas of the mine site to reduce the sulfate concentrations in the water that we're discharging. Just to put into perspective for people who don't normally deal with sulfates, what the sort of sulfate levels we're talking about, the standards that have been set for receiving water in the local lakes has been 100 ppm. The mineral water here that you can get at the finer bars and restaurants in Campbell River, if you have a look at the label, and SO4, that's sulfate, this particular bottle of mineral water's got a concentration of sulfate of 534.6 ppm. So when you're drinking this mineral water, you're drinking 5 times the level that's been set for the lakes. That just puts it in a little bit more perspective. Every week we take water samples from many different areas of the mine. The samples are sent to an independent testing lab for analysis. These are the water quality monitoring results for 2001. Each binder is 3 months worth of data. The water is tested for many different parameters, as you can see in these pages. Every 2 weeks we take a sample of the coarse and fine refuse. The samples are sent away to an independent lab for analysis. These are the results for 2001. You can see here all the different parameters that we're testing for. Then each quarter, the water quality and refuse analysis results are summarized and sent to the Ministry of Water, Land and Air Protection. These are the reports here. You can see here it's all the data that's in these other binders. Every year the water quality and refuse analysis results are compiled and analyzed and sent to the Environmental Technical Review Committee for review. These are these reports here. The results are analyzed and we list all the data that are contained in these reports here. You can see these tables here contain all those numbers. And a copy of this report goes into the Campbell River Public Library.
An additional project that has recently been completed by Quinsam Coal Corporation is the installation of a filter system at the Middle Point Coal Loading Terminal. The system, that includes a primary and secondary settling tank, pressure and sand filter, significantly reduces the suspended solids in terminal discharge water. An integral part of Quinsam Coal's environmental commitment includes the reclamation of the land disturbed by the mining process. Ongoing reclamation activities such as sloping, fertilizing, and seeding are completed at the site to stabilize disturbed slopes. Underground mine portals are sealed and reclaimed after mine abandonment, and some open pits have been partially backfilled in preparation for final reclamation. Final reclamation of the Quinsam coal mine will include the use of the land for forestry, recreation, and wildlife habitat. Since the purchase of the coal reserve, Quinsam Coal has spent millions of dollars towards the prevention and reduction of environmental impact. The reclamation program, along with the Middle Point treatment system and the sulfate sourcing and treatment project, are a part of Quinsam Coal's commitment to sustainable development.
Our company, Quinsam Coal, has a tremendous impact on the local economy of Campbell River. We have 55 full-time employees. Our wage roll amounts to approximately $5.5 million a year. And when you apply the normal economic multiplier effect to that, that's a substantial inflow into the local economy. In addition to that, we have a commitment to shop locally wherever possible. And I think a lot of the engineering companies and supply firms in Campbell River will attest to that. As well, we are committed to putting our resources back into the community. We support local children's charities and so forth. And so you'll see that there are numerous skating affiliations and baseball teams and hockey teams that we support in Campbell River and the surrounding district. Quinsam Coal is dedicated to providing a top quality product in a safe working environment, while at the same time providing economic benefit to the community now and into the future.